our group decided enough of fractions and pattern blocks and things like that. Let's work from the book. We just did a little bit starting in 3.2. And now we're on example 2. There were 3 ways to add fractions whose denominators didn't start out matching. We talked about this several weeks ago. You could do the brute force method. 12 times 18 will make a common denominator. But then you'll have to reduce like crazy. If you do a times 18 top and bottom to the 5/12ths and a times 12 top and bottom to the 7/18ths. So the brute force method started off quick, but then you had a lot of reducing to do at the end. There was also the list of multiples method, which some people really liked. List out 12 times 1, 12 times 2, 12 times 3. What are all the multiples of 12? And also list out 18 times 1, 18 times 2, 18 times 3. What are all the multiples of 18? And see what is the same on both lists. Let me write that down just so we have it. List of multiples. Because I know some people really liked this method.
I like that one.
So we had 12, 24, 36, 48, maybe that's enough. 18 times 2 is 36. Aha, I have something on both lists. So 36 will work. If I want to say 5/12ths, leave some space, plus 7/18ths, I can make them into 36. What did I need to do for the 12? Times 1, times 2, times 3. So this is a times 3 top and bottom. What did I need to do for the 18? That's a times 1, times 2. It's a times 2 top and bottom. You can just count in your list of multiples to see what to multiply by. Okay, then 5 times 3 is 15 of my 36. 7 times 2 is 14 of my 36. Add across the top. 15 and 14 is 29. Oops, that's not an equal sign. Can I reduce that? No, so I am done. Okay, but I think at least one, if not both people here, liked the third method, not the brute force method, not the list of multiple methods, but the prime factorization method. So let's do the same problem that way. Instead of listing the multiples of 12, we're going to make a little factor tree for 12. So 12 is, how do you want to split it? There's more than one option, but they will all work out the same.
3 times 4.
3 times 4, the 3 is done. The 4 is 2 times 2. Remember to either bring down the 3 or circle the 3. But you want to not lose track of these leaves on the tree, right? The farthest end things. Then the 18. It's not an 18, brain broken. Okay, 6 times 3. 3 is done. 6 is 2 times 3. Then to find our common denominator, we're going to start by picking all the factors on both trees and writing them down. And when we do, we cross out them on both trees. So there's a 2 on both trees. There's a 3 on both trees. And that's all that both trees shared, because the green tree doesn't have a second 2. And the blue tree doesn't have a second 3. So now I move on to part 2 of this. I've done the shared ones. Now I'm going to write the ones that only one tree has. And when I'm all done with that, I get my common denominator. If you do this a lot, you will get some sense of when this is the faster method to find 36, and when this is the faster method to find 36. And of course, if you practice them, then they get faster because you practice them. So it's not always true that one is the best compared to the other. It's just sort of which works best for those numbers. In general, the prime factorization method will more often be the quick way. But there we go. Okay, so let's go back to our solving the problem. 5/12, leave some space, 7/18. Before, we got the times 3s and the times 2s by counting along our lists. Where do they come from now? Well, this 12, this was the blue tree, right? This is our blue fraction. So we need to add to it what it didn't have. What was it missing? It was missing the green 3. You can see that 12 times 3 is now 36. Whereas the second fraction, the 18, that was our green tree. So what was missing from the green tree that the blue tree only had? That's the other 2. We're making the same bottom by filling in what's missing originally. So the blue was missing this times 3. The green was missing this times 2, so we put them in. You could also just divide. 36 divided by 12 is 3. 36 divided by 18 is 2. As before, now we have 15/36 and 14/36, which is 29/36. We're done because we can't reduce it.